Structural engineering is a branch of civil engineering that teaches students how to design the bones and muscle that give artificial structures their form and shape. Design, construction, and inspection of load-bearing structures such as significant commercial buildings, bridges, and industrial infrastructures are all part of this process. The practice of biomedical engineering is the design of systems, equipment, and devices for use in medical practice. Collaborating with the healthcare professionals such as physicians, nurses, technicians, therapists, and researchers is also part of the job to assess, analyze, and satisfy their needs for systems, apparatus, and devices. Chemical engineering is the profession of creating equipment, system, and processes for refining raw materials and combining, compounding, and processing chemicals to create valuable products. The practice of computer engineering is the creation of computer hardware components, computer systems, networks, and softwares. Designing and improving facilities, equipment, system, and methods for production, material processing, and various other work settings is the profession of industrial engineering. The practice of environmental engineering involves the prevention, reduction, and elimination of pollution sources that influence the air, water, and land. It also includes detecting and monitoring pollution levels, finding pollution sources, cleaning up and restoring contaminated location, and complying with local, state, and federal requirements. There is a typical much overlap between the various specializations. As a result, engineers must have a broad grasp of a variety of engineering discipline in addition to their area of expertise. A civil engineer, for example, must comprehend structural engineering ideas. An aerospace engineer must use mechanical engineering principles, and nuclear engineering must have work knowledge of electrical engineering. Engineers, in particular, require a thorough understanding of mathematics, physics, and computer application, like simulation and computer-aided design. This is why, before students choose to specialize in a particular subject, most college programs provide fundamental engineering classes in a variety of areas.
What do engineers do? According to the Bureau of Labor Statistics, engineers operate in various environments, including research labs, factories, building sites, nuclear power plants, offshore oil rigs, and even the International Space Station. Many engineers also own companies in their fields of expertise. For example, an HVAC engineer may own a heating and air conditioning firm, and a structural engineer might own a construction company. A bachelor's degree in engineering is required for the majority of engineering occupations. Many businesses and consultants demand state accreditation as a professional engineer, which includes completing an extensive and challenging test. A master's degree or a doctorate is usually required for senior engineering roles and professorships. Over the years, engineering has expanded along with our knowledge and understanding of science, mathematics, physical principles, and their applications. Engineers now design, develop, upgrade, operate, and maintain complex gadgets, structures, systems, and processes by combining well established scientific concepts with cutting edge innovations. Engineering got everyone out of the caves. Engineering brought us to the moon, and engineering will get us to the stars. Engineers will have more opportunities to put scientific findings to practical use as our knowledge grows.